Hi, in this video we are going to discuss about relationship between zeros and coefficient of a polynomial. Now let's take one example polynomial in variable x form. So p of x is 2x square minus 5x minus 3. Now when it is asked to find out zeros of a polynomial, that means we have to find out the value of x such that this polynomial 2x square minus 5x minus 3 will become 0. That means p of x must be 0. Now the actual polynomial is 2x square minus 5x minus 3 and that must be 0. Now this is one quadratic equation and we need to solve this equation. For this we need to factorize. Now let's split the middle term. Let's split the middle term so that we will get the factors of polynomial 2x square minus 5x minus 3. For this we need two numbers such that their sum is the coefficient of middle term. Now the coefficient of middle term is minus 5. So we need two numbers such that their sum is minus 5 and the product of two numbers must be coefficient of x square, which is 2, multiplied by the constant term, which is minus 3. So we need two numbers such that their product will be 2 into minus 3, that is minus 6. Now let's use the product minus 6 to find out the pair of values. So let's begin with number 1. 1 into minus 6 will give us minus 6. Then next number is 2. 2 into minus 3 will give us minus 6. Then 3. 3 into minus 2 will give us minus 6. 4 and 5 will not consider because they will not form pair. And the next number is 6. 6 into minus 1 will again give us minus 6. So these are available pairs. Now out of these pairs, only the first pair 1 minus 6 will give us sum minus 5. So this pair 1 minus 6 will give us sum minus 5. Hence this is correct pair. That means we can split the middle term minus 5x into 1x minus 6x. So let's rewrite the equation by splitting the middle term. 2x square plus 1x minus 6x minus 3 is equal to 0. Now it is not necessary to write 1x. You can simply write x, but for the sake of understanding we are writing it as 1x. Now let's form pair of first two terms and last two terms. Now from the first pair we can take x common and what remains inside bracket is 2x plus 1. So 2x into x will give us 2x square, 1 into x will give us 1x. From the second pair we can take minus 3 common and what remains inside bracket is 2x plus 1. Now 2x into minus 3 will give us minus 6x and 1 into minus 3 will give us minus 3. That must be 0. Now we can take 2x plus 1 out as it is common and what remains inside bracket is from the first term x and from the second term minus 3. So that must be 0. To have the value of equation as 0, either the first factor should be 0 or the second factor should be 0. That means we should have either value of first factor as 0 or second factor as 0. Then only this equation will have value 0. Hence we can write it as in the equation form 2x plus 1 must be 0 or x minus 3 must be 0. Now subtracting 1 from both sides will get 2x is equal to minus 1 and dividing by 2 we get x is equal to minus 1 by 2. For the second equation, if we add 3 to both sides, we get x is equal to 3. Now at value of x equal to minus 1 by 2 and 3, this equation becomes 0. Hence, minus 1 by 2 and 3 are called as zeros of this polynomial 2x square minus 5x minus 3. Now let's name the zeros of the polynomial as alpha and beta. So alpha will be minus 1 by 2 and beta will be 3. Let's write down the zeros of the polynomial. Zeros of polynomial 2x square minus 5x minus 3 are alpha is the first value, minus 1 by 2, then beta is 3. Now let's find out two more terms based on the zeros of the polynomial. The first term is sum of zeros. So we want to find out sum of zeros. That means sum of alpha and beta. Alpha is minus 1 by 2 and beta has value 3. So we need to add these two values. LCM of the two numbers is 2. Minus 1 will remain as it is and 3 into 2 will give us 6. So after simplifying we get the sum of zeros as 5 by 2. Now let's find out the product of zeros. So we want to find out product of zeros as well. That means alpha into beta. So the value of alpha is minus 1 by 2 into beta is 3. So that will give us the result as minus 3 by 2. So the product of zeros is minus 3 by 2. Now let's write down the coefficient of the polynomial as well. So coefficient of polynomial are for x square. For x square, the coefficient is 2. For x, the coefficient is minus 5. We have to consider the sign of the coefficient as well. And for the constant term, we have coefficient as minus 3. Now we want to check if there is any relationship between the zeros of the polynomial and the coefficient of the polynomial. So our goal is to find out this relationship. Now let's write down the sum of zeros again in different form. So sum of zeros is 5 by 2. Now 5 by 2 can be rewritten as minus and in the bracket minus 5 by 2. Now if you observe carefully, minus 5 is nothing but coefficient of x. So we can write instead of minus 5 coefficient of x divided by what is 2? 2 is nothing but coefficient of x square. So we can write it as coefficient of x square. Okay, so sum of zeros is nothing but minus coefficient of x divided by coefficient of x square. Now let's check the other term, product of 0, and let's find out is there any relationship between the product of zeros and the coefficient. So here minus 3 is nothing but constant term. So minus 3 we can write it as constant term divided by 2. So what is 2? 2 is nothing but coefficient of x square. So this is nothing but coefficient of x square. Hence we have established the relationship between the zeros of the polynomial and the coefficient such that sum of zeros is nothing but minus coefficient of x divided by coefficient of x square, and product of zeros is nothing but constant term divided by coefficient of x square. In previous video we discussed relationship between zeros and coefficient of a polynomial by taking one example polynomial. So let's prove this relationship. So we'll take a polynomial in generalized form. So the polynomial is a quadratic polynomial, ax square plus bx plus c. Now this polynomial has degree 2, hence it is a quadratic polynomial, and one more important condition is a is not equal to 0. If a is 0, then this becomes a linear polynomial, because 0 into x square will become 0 and this will give a linear polynomial. Now let's assume alpha and beta are the zeros of this polynomial. Alpha and beta are the zeros of the polynomial. So that means one of the factor of this equation is x minus alpha, which will have value 0. Then another factor will be x minus beta. This will also have value 0. So we'll get, if we multiply the two terms, we'll get product as 0. Now let's multiply both sides by a constant k. So multiplying by k, what we get? K into x minus alpha into x minus beta must be 0. If we multiply 0 by k, we'll get 0. So this is result of multiplying by a constant k. Now let's multiply x minus alpha and x minus beta. So what we get? X into x will give us x square, minus x into alpha will give us minus alpha x. Then let's multiply by beta. Minus beta into x will be minus beta x, plus minus alpha into minus beta will be plus alpha beta. This must be 0. You can see that the middle two terms has x as common. So we can take x common from the middle two terms. So x square will keep as it is, minus, both terms have minus sign, then into bracket alpha plus beta into x. So alpha into x will give us alpha x, then beta into x will give us beta x, and preceded by minus sign, plus alpha beta must be 0. Now let's multiply by k. So k into x square will be kx square minus alpha plus beta into the constant k into x plus alpha beta k, that must be 0. Now at the end of this step we got one quadratic polynomial. Now this quadratic polynomial is nothing but the original polynomial x square plus bx plus c. So this polynomial is nothing but x square plus bx plus c. So this is equal to 0. Now the first term is equal to x square, the second term is equal to bx, and the third term is equal to c. Now let's take only the constant portion of the term. So k must be equal to a. So x square will get cancelled out, and we get first result as k is equal to a. Now from the second term what we get? Minus into bracket alpha plus beta into k must be equal to b. Now that means if we divide both sides by minus k, what we get? Alpha plus beta is equal to minus b by k. So we know that k is nothing but a. So this can be written as, replacing k by a, what we get? Alpha plus beta is equal to minus b by k is nothing but a. So minus b by a. Now let's write down the constant term as well. So what we get? Alpha beta k. Alpha beta k is equal to c. That means if we divide both sides by k, we get alpha into beta is equal to c by k. Now what is k? K is nothing but a. So alpha into beta. So alpha into beta is equal to c divided by what is k? K is nothing but a. Alpha plus beta is nothing but sum of zeros, which is equal to minus b by a, and product of zeros alpha into beta is equal to c by a. Now b is nothing but coefficient of x, then a is nothing but coefficient of x square. For product of zeros alpha into beta, c is nothing but the constant term divided by the coefficient of x square. So this way we can prove the relationship between the zeros of the polynomial and coefficient of the polynomial. Now let's write down the result of above proof. So the result is sum of zeros is equal to minus b by a. That means minus b is coefficient of x divided by a. A is nothing but coefficient of x square. A is coefficient of x square. So sum of zeros is equal to minus coefficient of x divided by coefficient of x square. Now what is product of zeros? So alpha into beta, that means product of zeros is equal to c by a. C is nothing but the constant term. So constant term divided by a. A is nothing but coefficient of x square. So this is the relationship between zeros of a polynomial and the coefficient of a polynomial.